Dr. D. Govardhan, Professor and Head, Department of Aeronautical Engineering, Institute of Aeronautical Engineering, Hyderabad. Today, I am covering the definition and terminologies in linear impulse momentum, conservation of momentum, and mechanical vibrations. Linear impulse and momentum. Let F1, F2, F3 and F4 are the forces reacting on object as shown in figure. Let A is representing the initial position. After time t seconds, it is reached B position as shown in figure. Let U be the representing the initial velocity of the body, and V be the representing final velocity of the body after t seconds, and S is the distance covered. Now, since the body is moving toward the right hand side with an acceleration of A, hence the resultant of all the forces F1, F2, F3, F4, if it is equal to R, it always acts in the direction of motion of the body, that is represented here X now. So, we can write that equation as R is equal to M into A now, where M is representing the mass of the body, A is the acceleration with which the body is moving now. But acceleration is the rate of change of velocity, hence it can be written as now dV by dt now. Or in other words, R is equal to, we can write it to M into dV by dt now. Or R into dt is equal to M into dV now. So on integration these equations from 0 to t time now, that is the velocity is also changing from U to V as shown in figure. It can be written as R into dt integration from 0 to t is equal to integration of M dV from the limits U and V as shown in figure, which is equal to M V minus M U now. This is called here now. M, the product of mass and velocity, is called the momentum. So, this is called change in momentum. That is R into dt is equal to change in momentum. Where the word R and dt is called impulsive. That is the product of force and time. Hence, the units are Newton, seconds, and R and dt here we discussed now. It has impulsive, which is equal to change in momentum. That is final momentum and initial momentum. So, here momentum is a vector quantity. It is having particular directions, and F1 dt, that is the impulse, is equal to force multiplied by the time. It is also the product of vector as the scalar, but it is finally it is a vector quantity. So, here the momentum, impulse, both are treated as vector quantities. Conservation of momentum. If the resultant force which is acting on the body, if it is equal to 0, the momentum is said to be conserved. That means here in previous equations, we are having R into dt is equal to change in momentum, that is the mv minus mu. Since the resultant force, if it is equal to 0, that is the R into t is equal to 0, then mv minus mu is equal to 0, or the momentum possessed by the body at initial position should be equal to the momentum possessed by the body at a final velocity. Hence, the conservation of momentum can be stated as the momentum is conserved in a system in which the resultant force is 0 now. That is, the momentum possessed by the body remains constant. Impulsive momentum method now. Impulse is the product of force and time, and it is also vector quantity. Similarly, the momentum is also, it is a product of mass and velocity. It is also vector quantity. Here we are considering the object, it is moving. From initial positions, it is represented A now, to final position B, as shown in figure. Let V1x is representing the velocity of the body at initially, and V2x is representing the velocity of the body at B position now. So according to the impulse momentum equations, the Fx into dt from the limits that 1 to 2 points is equal to change in momentum. M is a constant now. Btx minus V1x, we can take it now. Or similarly, if the body is moving in a plane now, that velocity can be resolved into two components, x direction as well as the y directions. At the same time, the R is also, when it is resolved into two components, we can take it that x directional force as now x, that is Fx into dt is equal to m into v2x minus v1x. Similarly, when the force as well as the velocity is resolved in y directions, we are having again the integration of fy dt from the limits 1 and 2 equal to m into v2y minus v1y now, where Fx is representing the impulsive force in x directions, Fy is representing the impulsive force in y directions, and v1x and v2x are the velocity of the body at 1 and 2 along the x directions, and v1y and v2y representing the velocity of components at a points 1 and 2 in y directions, where F is representing the resultant of force, which is the equal to the under root of Fx square plus Fy square now. The inclination with which the force is acting or the body is moving, it is given by tan theta is equal to Fy divided by Fx. Generally, here the momentum is nothing but product of mass and velocity of the body. Generally, it can be defined as mass in motion. All the objects have mass, so if an object is moving, then it has a momentum. The momentum depends upon the variables mass and the velocity now. Hence, here now, general word, the momentum is defined as mass in motion, which is equal to the product of mass and velocity. Here it can be written as equation P is equal to M into B now. The definition of the collisions. When a ball hits the ground and sticks, the collision would be totally inelastic. That is nothing but it will not come in upward directions. The best example is the stone is there. When it is hit the ground, it will not move or rebound in upward directions. Hence, this collision is treated as inelastic collisions. But when a rubber ball hits the ground, it bounces certain height now. Maybe sometimes it will come to up to the certain position now, that is, from which it is a false now. Sometimes it may be rebound at a certain height now. Then the collision is said to be elastic. All other collisions are partially elastic collisions. Phenomena for collisions. When two elastic bodies collide with each other, already we discussed that is elastic body means when it hit the ground, it will rebound certain height from the surface of the ground. That collision is elastic now. The bodies are called here now elastic bodies now. When the two bodies, elastic bodies collide with each other, the phenomena of collision takes place as given below. At initially, the bodies immediately after collisions come momentarily at rest. The two bodies tend to compress each other so long as they are compressed to the maximum values. After that, they will come to rest position. After momentarily coming to the rest, the bodies attempted to regain its original shape due to their elasticity. This process of regaining the original shape is called restitution. Okay, coefficient of restitution now. Here consider the two bodies A and B as shown in figure. Let mu1 is representing the initial velocity of the first body, here 1, and v1 is representing the velocity of the first body, that is the final velocity of the first body. Similarly, u2 represents the initial velocity of the second body, and v2 representing the final velocity of the first body. Already we discussed the phenomena of collisions now. When these two bodies are collided with each other, the elastic bodies momentarily before coming to the rest, they are gradually compresses and reaches maximum values. At that moment, that velocity now becomes 0. After that, the bodies regain its original shape and moves within certain velocity as shown in figure now. The process of regaining their shape is called restitution now. Here it is representing, first figure is representing the two bodies before impact. Here, according to this position, u1 is greater than u2 now. This after impact again now. In restitution process, they are separated now. In this case, since the body v2 is having more velocity than the v1 now. Here the difference of u1 and u2, that is the initial velocities of object 1 and 2. Here the difference of these two velocities are treated as the velocity of approach. That is velocity of approach is equal to u1 minus u2 now. Similarly, after collision, the v2 is having more in velocity than the v1. So the difference of the relative velocity of v2 and v1, that is v2 minus v1, is representing the velocity of separation. Generally, it is represented as v2 minus v1. Here it is called velocity of separations. Now, as per the Newton's law of collision of elastic bodies, the velocity of separations behaves a constant ratio with the velocity of approach. That means v2 minus v1 equal to some constant e we are taking into u1 minus u2 now, where e is treated as a constant now. Generally, it is called as coefficient of restitution. Its values generally lies between 0 to 1. If e is equal to 1, 0, the two bodies are said to be inelastic. If it is equal to 1, the bodies are said to be perfectly elastic. But for the most of the bodies, the values lies between 0 to 1 only. Types of collisions. When the two bodies are collided with each other, generally they are said to be have an impact. There are two types of impacts generally taking place when the two bodies are collided with each other. They are known as direct impact, and the second one is known as indirect impact. Sometimes it is also called oblique impact. Direct collision of two bodies. It is also called the line of impact. In this case, when when the line impact is taking place between the two colliding bodies, means the line joining the center of these bodies and pass through a point of contact or point of collision as shown in figure. That means in direct collisions, or it is also called line impact, the line joining the centers C1 and C2 of two colliding bodies is always passed through the point of collisions. Then this type of collisions are called direct impact or line collisions. If M1 is representing the mass of the first body and E1 is representing the initial velocity of the first body, V1 is representing final velocity of the first body after the collisions, M2, U2, V2 representing corresponding values for the second body, that is the B, which is shown in figure. Then, according to the law of conservation of momentum, the momentum possessed by the bodies before the collision should be equal to the momentum possessed by the bodies after the collisions. That means M1 E1 is plus M2 V2 is equal to M1 V1 plus M2 V2 now. If the velocity of bodies is taken as positive in one direction, when they are moving in the same directions, and the negative when the bodies are moving in opposite directions while calculating the relative velocity. If one of the bodies is initially at rest, such a type of collisions are called impact. Indirect collision of two bodies, or it is also called indirect impact. Here, in line of direct impact, the line joining the centers with the point of contact, that is the point of impact, should be lie in the same line. Then it is called direct impact. In this case now, if the two bodies before the impact are not moving along the line of impact, that is not in the same direction, because it is nothing but coming this directions, this object is nothing but moving this direction, both are not having the same direction. The collision is called an indirect impact, it is also called oblique impact. So here the first body C1, it is nothing but A and B. They are moving in the direction of alpha 1 with the horizontal line as shown in figure. Similarly, the second object B is also before impact or the collisions, it is coming with an inclination of alpha 2 with the line joining AB as shown in figure. So this type of impact is called here now indirect impact. It is also called oblique impact. That is, the two bodies are not at all moving in the same lines which before the collisions. Okay, in definitions, vibrations. Now first we are giving the definition of simple harmonic motions. Okay, let us consider the object P, it is there. It is moving along the circumference of the circle with a uniform angular velocity omega as shown in figure in counterclockwise directions. At time t, assume the position of the body at P as shown in figure. Then its projections on vertical diameter. Vertical diameter is represented here now, y and y dash is at end position now. When the body reaches its y position, the n is also pointed with the y as shown in figure now. Again, when a point P moves from Y to X dash position now, its projection on vertical diameters moves Y to O position now. Again X dash to Y dash position, it comes to O to Y dash positions. Again Y dash to X, again it goes to Y dash to O position. That means when the point P is moving along the circumference of the circle with a uniform velocity, its projections always oscillates along the vertical diameter as shown in figure. That means if it is completed one P point, if it is completed one revolution, the point N also complete one vibrations about the point O now. This to and fro motion of the point N is known as simple harmonic motions. Briefly, it can be written as SHM now. So for the equation of simple harmonic motions, here Y is assumed this representing the distance between O and N now. So it can be written as according to the trigonometric relations now. OP is representing R now. ON is equal to, we can take it as R sin theta. But theta is representing angular displacement, which is equal to the product of angular velocity and time. Hence it can be written as R sin omega t now. So the velocity is given by dy by dt is equal to omega into R into cos omega t now. So velocity is equal to, or it can be written as now, omega into cos omega t is equal to omega r into cos omega t is equal to 1 minus sin square omega t, which is equal to omega r into under root of 1 minus y by r whole square under root. Simply it can be written as now v is equal to omega into under root of r square minus y square. Now differentiating these equations once again to get the acceleration now, that is dy by dt square, it is equal to minus half omega r square omega. Once again this equation now, we got it to omega square into r sin omega t now. It is nothing but minus half it is there. Or we can write simply this A is equal to this minus half omega square by now. So it can be written as a omega square into r sin omega t now. The minus sign shows the when the body is moving in simple harmonic motions, its acceleration is always directed toward the equilibrium position or at the center position now. So this property here now, that is the acceleration is always directed toward the point O. This is called here the fundamental property of the simple harmonic motions. That is when the body is oscillating, that is having simple harmonic motions, the acceleration is always directed toward the equilibrium position or the center now. Okay, general conditions of simple harmonic motions. In general, the body is said to be move or vibrate with the simple harmonic motions. It has to satisfy the following two conditions. The first one is its acceleration is always directed toward the center. It is also known as the point of reference, or it is also called mean position. Its acceleration is proportional to the distance from the point, because we are taking A is equal to minus of omega square y now. That is the magnitude it increases with the y values increases. That means the acceleration increases with the y, or in other words, the acceleration is proportional to the distance from the mean position, and the acceleration always acts in the opposite direction in which the body is tends to move, or in other words, it is always directed toward the center position. Okay, some important terms just using vibratory motions. They are now amplitude now. It is the maximum displacement of the body from its mean position. That here mean position is treated as assume just a O position now. And A and C is nothing but representing the extreme position now. The maximum displacement of the body from its mean position, that is from O to C positions, this is nothing but treated as the maximum displacement of the amplitude of the body now. Here in this case now, OY and O dash is the amplitude of the particle and the amplitude is always equal to the radius of the circle according to the previous notations. Cycle means it is the motion completed during the one time period. Oscillations, if it is a complete vibration of the body, in figure number 1, when the body moves from Y to Y dash position and then back to Y, it's said to have completed on oscillations. Just I am giving the definitions once again by using this figure. Is moving, the point P is moving along the circumference circle in counterclockwise directions with uniform velocity. Its projections are always just move along the vertical diameter as shown in figure. Here, first when we are taking, that is the amplitude now. The amplitude is treated as the maximum displacement of the body from its mean position. That means, according to this figure, the end point is having here simple harmonic motion. It is having maximum displacement means we need to consider with the Y position or Y dash position. That means the maximum amplitude is equal to the radius of the circle according to the figure 1 now. The second one is cycle. Here, if it is a completed, the motion of the body, that is simple harmonic motions, in one time period, it is called a complete cycle. That means according to the problems, it has to come to Y to Y dash position, again Y dash position to Y, then it is said to be having one complete cycle. Oscillation, it is one of the complete vibration of the body in figure number 1. That is coming to Y to Y dash position, then back to Y is called here oscillations. The beat, it is half of the oscillations, because oscillation nothing but we are taken now from Y to Y dash position and Y dash position to again Y positions. It is called here now complete oscillation. The half means nothing but this Y to Y dash positions. Here it is treated as a beat now. That is the half of the oscillations. Periodic time. Periodic time is defined as the time taken by the oscillating body for one complete oscillations. Time taken by the particle when it is having simple harmonic motions for one cycle or one oscillation. It is called periodic time. Generally, it is equal to T is equal to 2 pi by omega, where omega is representing the angular velocity of the body which is moving along the circumference of the circle now. The frequency, the number of cycles completed by a oscillating body in 1 second, it is called frequency. Generally, it is represented as 1 by T, where T is representing the periodic time now. It is generally the frequency is expressed in terms of H, that is number of cycles per seconds. Types of vibrations. Generally, vibrations are classified into 3 types now. One is free or natural vibrations. The second one is forced vibrations. Third one is damped vibrations. The free or natural vibrations, when a disturbing force is acting on the body, when it is displaced from its original position, after removal of the disturbing force, the body oscillates that to and fro. The type of vibrations are called natural vibrations. That means when it is vibrating, there is no external forces acting on it. That are called free or natural vibration. When no external force acts on the body, after giving a small initial displacement, that is nothing but disturbing forces acting on it to move the body from its equilibrium position. After that, the force which is acting on the body it is removed. The body, if it is execute vibrations, that type of vibrations are called natural or free vibrations. The frequency of the free vibrations is called the free or natural frequency. Forced vibrations. When the body vibrates under the influence of external force on each revolutions or each oscillations, the type of vibrations are called forced vibrations. That is, when the body vibrates under the influence of external force, the body is said to be under forced vibrations. The external force which is applied on the body is having just a periodical disturbance. That means it will act on the body at every cycle. That is, the frequency of the disturbing force is equal to the frequency of the vibrating body. This type of frequency is called forced vibrations frequency. When the frequency of the external force is same as that of the natural frequency, the resonance is taking place now. It will increase the amplitude of the vibrating body. At the same time, it also gives the noise which causes the damage to the parts which are moving related to each other. In damped vibrations, here the amplitude of the vibrating systems reduced for every cycle of vibrations, then the motion is said to be damped vibrations. This is the fact. This is due to the fact that when the system is vibrating, some external forces which are acting on it. The best example is the cradle is there now. The air is also offer some resistance to move the body in the directions. Hence, because of the resistance forces, the amplitude of the vibrating system gradually decreases for every cycle. The type of vibrations are called damped vibrations. So, types of free vibrations. That means, first of all, we classified the vibrations into three types. Free or natural vibrations. The second one is forced vibrations. The third one is damped vibrations. The first free or natural vibrations further classified into three types: longitudinal vibrations, transverse vibrations, and torsional vibrations. Longitudinal vibrations. In longitudinal vibrations, the vibrating body or the body oscillates along the axis of the shaft. Okay, in this case, assume the shaft is suspended freely, having negligible mass. A disc is attached at its end at a B position as shown in figure. When external forces is applied to disturb its position from equilibrium position and released, it executes vibrations. These vibrations are called natural or free vibrations. But the vibrations are taking place along the length of the shaft. That is, the length of the shaft is increases as well as the decreases for every oscillations. Hence, compressive as well as the tensile stresses are induced in the shaft. In transverse vibrations, the vibrational object always taking place approximately perpendicular to the axis of the shaft when the amplitude of the vibrating system is very small. These type of vibrations are called transverse vibrations. That is, when the particle of the shaft or the disc moves approximately perpendicular to the axis of the shaft, the type of vibrations are called transverse vibrations. In this case, since the shaft is bending alternatively, and hence bending stresses are induced in the shaft. When the particle of the shaft or the disc moves in a cycle about the axis of the shaft as shown in figure, that is, the twisting as well as the untwisting is taking place during these vibrations. These type of vibrations are called torsional vibrations, and during the twisting and untwisting, torsional shear stresses are induced in the shaft. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.